The violent, bone-crushing roar of the launch is over. Millions of pounds of thrust have finally exhausted themselves, leaving behind an immediate, suffocating silence. Inside the Orion capsule, the intense vibration that threatened to rattle the teeth from the astronauts' skulls has vanished. Gravity releases its heavy, suffocating grip. They unbuckle. They float. Drifting toward the small, multi-layered glass of the viewing window, they look back at what they have just survived. Earth fills the frame. It is vast, intensely bright, and wrapped in a glowing, razor-thin halo of blue atmosphere. From here, it looks entirely peaceful. It looks like a sanctuary. But as the Artemis II crew prepares for the final engine burn that will hurl them out of Earth's orbit and into the deep, dark expanse toward the moon, a profound psychological shift occurs. They are not just leaving home. They are leaving the only true armor humanity has ever known. They are about to cross a terrifying, invisible threshold, abandoning the safety of our planet's ancient shield to step out into an ocean of lethal, invisible fire. Space is unapologetically hostile. We easily understand the immediate mechanical dangers of leaving our atmosphere. We know about the absolute vacuum of the void, a pressureless expanse that would boil the liquids in the human body in a matter of seconds. We understand the staggering thermal extremes, where plunging into the shadow of a celestial body drops the temperature hundreds of degrees below zero, while stepping into the direct glare of the sun cooks the surface of a spacecraft. We know about the microscopic shrapnel of micrometeoroids, tiny fragments of ancient rock and comet dust traveling at hypersonic speeds, easily capable of punching through solid metal like a sniper's bullet through paper. But against all of these mechanical and thermal threats, human ingenuity has triumphed. We can engineer our way out of those problems. We build pressurized titanium vessels. We weave complex multi-layered thermal blankets. We armor the hulls of our ships with reinforced shielding. Against the physical violence of the cosmos, we have built a fortress. Yet, there is a phantom lurking in the absolute blackness of deep space. It makes no sound. It casts no shadow. It cannot be stopped by standard armor, and it passes through steel and human flesh with terrifying ease. As the Artemis II crew pushes farther from Earth than anyone has traveled in over half a century, they will be utterly immersed in this phantom threat. They will face the unrelenting ambient bombardment of cosmic radiation. And the chilling reality of their historic mission is that against this specific, insidious danger, there is no true escape. To fully grasp the magnitude of what these 4 astronauts are facing, we have to recognize the staggering privilege of simply standing on the surface of the Earth. Thousands of miles beneath our feet, a churning, chaotic ocean of superheated liquid iron swirls relentlessly around a solid inner core. This planetary dynamo acts as a colossal generator, projecting a massive magnetic field that erupts from the poles and loops far out into the vacuum of space. This invisible bubble is called the Magnetosphere, and it is the single reason life on this planet has not been completely sterilized. The universe is awash in a chaotic crossfire of lethal radiation, high-energy particles traveling at massive fractions of the speed of light. If Earth did not possess this magnetic shield, these particles would systematically strip away our protective atmosphere. They would scorch the surface of the globe, mutating and destroying cellular biology until our lush blue world was reduced to a barren, irradiated wasteland, sharing the tragic fate of Mars. Even when astronauts live and work aboard the International Space Station, they remain the beneficiaries of this invisible armor. They are certainly exposed to higher doses of background radiation than we are on the ground, but they are still flying in low Earth orbit, nestled deep within the protective embrace of the magnetosphere. The magnetic shield extends tens of thousands of miles beyond their altitude, catching and deflecting the vast majority of the cosmic barrage before it ever reaches them. But the moon sits nearly 250,000 miles away. To reach it, the Artemis II crew must do what only 24 human beings in the entire history of our species have ever done. They must leave the bubble. They must pierce the veil of the magnetosphere and venture into the unprotected void. The moment the Orion spacecraft crosses that invisible boundary, the environment fundamentally and violently changes. Inside the cabin, the digital dosimeters will begin to register a sharp, unmistakable spike. The crew will suddenly find themselves in the deep space radiation environment, a domain ruled by two entirely different, deeply terrifying phenomena. The first of these is the relentless, ambient rain of galactic cosmic rays. The name itself sounds almost benign, perhaps even poetic, but the physical reality is monstrous. Galactic cosmic rays are not rays of light at all. They are physical objects. They are the heavy atomic nuclei of elements like helium, carbon, and iron that have been violently stripped of their surrounding electrons. They were forged in the cataclysmic deaths of ancient stars, hurled across the universe by the staggering shock waves of supernovae that detonated millions of years ago. These heavy, jagged, subatomic wrecking balls have been traveling through the frozen void for eons, accelerating to near the speed of light. They carry an immense amount of kinetic energy. When they strike the metallic exterior of the Orion spacecraft, they do not simply bounce off. They smash right through the exterior shielding, colliding violently with the atoms of the hull. This high-speed impact shatters the metal atoms, creating a chaotic secondary shower of subatomic shrapnel, neutrons, and other particles that ricochets wildly through the interior of the crew cabin. When one of these heavy ions, or its secondary shrapnel, intersects with a human body, the microscopic damage is catastrophic. It tears through soft tissue like a microscopic bullet. If it strikes a living cell, it can physically snap the delicate double helix of the astronaut's DNA. The human body is remarkably resilient, and our cellular machinery has evolved incredible mechanisms to repair minor DNA damage. But galactic cosmic rays do not cause simple, clean breaks. They cause complex, clustered fractures in the DNA structure that our terrestrial biology simply did not evolve to understand or fix. The cell is left crippled. It either dies outright, or far worse, it mutates. This is the slow, silent, guaranteed toll of deep space exploration. Every single second the Artemis II crew spends outside the Earth's magnetic field, their cellular structure is under siege. It is an ambient degradation, locking in a statistically guaranteed increase in their lifetime risk of developing aggressive cancers, central nervous system damage, and severe degenerative cardiovascular diseases. Yet, galactic cosmic rays are merely the background noise of the universe. They are a constant, predictable danger that engineers can calculate and doctors can monitor. The second threat waiting for them in the dark is far more immediate, highly chaotic, and profoundly lethal. It comes from the very star that gives us life. Our sun is a turbulent, violently boiling sphere of plasma, driven by magnetic forces so powerful they defy human comprehension. Occasionally, these magnetic fields twist tightly upon themselves, snapping and realigning in sudden, catastrophic bursts of energy. These are solar flares. Often, they are accompanied by coronal mass ejections, events where the sun literally violently vomits billions of tons of radioactive plasma outward into the solar system. When this happens, it triggers a solar particle event. A shockwave of highly energized protons accelerates outward, washing over the inner planets like an invisible radioactive tsunami. During the Apollo era, the astronauts were granted an incredible historical stroke of luck. The lunar missions of the 1960s and 70s were relatively brief, lasting only a week or two. By sheer, staggering chance, they managed to slip perfectly between the raindrops of major solar storms. But the margins of that luck are terrifying to look back on. In August of 1972, sitting squarely in the timeline between the historic flights of Apollo 16 and Apollo 17, the Sun unleashed one of the most powerful and violent solar storms ever recorded by human instruments. Down on Earth, our planetary magnetic shield absorbed the brunt of the blow, though the immense electromagnetic surge still caused power grid disruptions and triggered the erratic detonation of magnetic sea mines. But out in the deep space corridor between the Earth and the Moon, the radiation levels spiked to universally lethal concentrations. If an Apollo crew had been caught out there, housed inside the incredibly thin aluminum skin of their command module, they would have been doomed. If they had been walking on the lunar surface in their fabric spacesuits, the reality would have been even grimmer. They would have absorbed a fatal dose of radiation in a matter of hours. The onset of acute radiation sickness would have been rapid and brutal. They would have suffered severe, incapacitating nausea, massive internal hemorrhaging, and a rapid breakdown of their central nervous systems. They would not have survived the journey home. The engineers and flight directors commanding the Artemis program cannot and will not rely on the profound luck of the Apollo generation. The Artemis II mission is a longer, incredibly complex test flight, specifically designed to push the Orion spacecraft and its crew to their absolute operational limits. But because they are flying a longer trajectory, their window of exposure to the unpredictable wrath of the Sun is significantly wider. We watch the Sun constantly. We have an entire armada of satellites dedicated to monitoring its volatile surface. But predicting a massive solar flare is much like predicting a devastating earthquake. We can observe the warning signs, we can identify massive, dark sunspots, and track twisting magnetic complexities. But we cannot say with absolute definitive certainty exactly when a massive eruption will detonate until the initial flash of brilliant light is already captured by our lenses. And because that light travels at the absolute speed limit of the universe, by the time we see the flare, the deadly radiation is already hurtling toward us. If the Space Weather Prediction Center detects a massive, Earth-directed solar eruption while Artemis II is in transit, a deafening alarm will trigger in mission control. The flight director in Houston will immediately open a radio channel to the crew. The message will be calm, highly technical, and utterly chilling. They will be informed that a wall of solar radiation is inbound.
I repeat, seek shelter immediately.
Depending on the sheer velocity of the accelerated particles, the astronauts might have just a handful of hours, perhaps even just minutes, to prepare for the onslaught. This scenario exposes a psychological reality of deep space travel that is almost incomprehensible to those of us standing firmly on the ground. Out there, in the blackness, there is nowhere to run. The Orion spacecraft cannot abruptly change its trajectory and hide behind a celestial body. It cannot throttle up its engines to outrun a storm that is moving at a massive fraction of the speed of light. The crew must face the brunt of the storm inside the cold, confined, highly technical space of their tiny capsule. On Earth, protecting ourselves from intense radiation is a matter of brute force. We build thick, impenetrable walls of solid lead or heavily reinforced concrete. We bury our containment bunkers deep underground. But in the realm of spaceflight, mass is the ultimate enemy. Every single pound of shielding requires thousands of pounds of highly volatile rocket fuel to lift out of Earth's gravity well. The Orion capsule simply cannot be armored with lead plates. It would be far too massive to ever leave the launch pad. Therefore, NASA engineers had to devise a completely different survival strategy. They had to teach the crew how to use the mundane materials already packed inside the capsule to build an improvised sanctuary. When the solar storm warning comes through their headsets, the 4 astronauts will immediately abandon their nominal tasks and scramble to the central bay of the Orion capsule. They will begin frantically unstowing heavy equipment bags, tightly packed clothing, and precisely molded containers of drinking water. Water is exceptionally effective at absorbing radiation, specifically the high-energy protons hurled by the sun, because it is incredibly rich in hydrogen. They will use these dense, tightly packed stowage bags to construct a makeshift, dense shelter right in the middle of the small crew cabin. They will wedge their bodies into this tiny, claustrophobic cavity, literally building a wall of their own supplies and drinking water, using them as makeshift sandbags against a radioactive flood. And then they will wait. As they sit in the absolute darkness of their improvised shelter, waiting out the invisible storm, the astronauts will likely begin to see vivid flashes of light, bursts of intense blue and stark white. Jagged streaks and blooming starbursts will dance across their vision. But against the invisible, silent fire of deep space radiation, there is absolutely nothing they can actively fix. In the face of a solar storm, they are entirely stripped of their agency. They must simply sit in the belly of their machine. When the Orion spacecraft sweeps around the far side of the moon, plunging into the deep, inky shadow of the lunar surface, the crew of Artemis II will be farther from home than any human being has been in generations. They will watch the Earth slowly rising over the barren, heavily cratered horizon of the moon. A fragile, intensely glowing blue marble, suspended completely alone in the endless, suffocating black. From that staggering distance, the Earth does not look like a mighty, indestructible world of billions. It looks incredibly small. It looks like a single, delicate, breathing organism. It looks like a lifeboat. They will understand the true, heavy cost of leaving the sanctuary. The universe does not welcome us into the dark. It actively, relentlessly tries to tear us apart. But we go anyway. We push our ships through the invisible fire. We endure the silent cosmic storms. And we sacrifice our own safety because the burning desire to see what lies beyond the horizon will always be stronger than our fear of the dark. We go because if we never dare to step out of the sanctuary, we will never truly know the stars.